All right, we're going to just start our discussion about Chapter 16 with a little pretend game. So you're going to pay $5 to play this game. Maybe it's like at a carnival, maybe a lagoon. You draw a card at random from a deck of cards. If you get the ace of hearts, I'm going to give you $100. If you get any other ace, you can win $10. Any other heart, you get $5. And all the rest of the cards you lose. I keep your $5. So should you play? Now I know some of you will be really eager because you love games of chance, but we're going to focus in on should you play, analyzing the amount of money you would win, and put some mathematics behind that answer. So what we're discussing here, the amount of money you could possibly earn is called a random variable. Sometimes you'll see RV for short. We call it a random variable because the amount of money you earn is variable. It changes. Okay, you could earn different amounts. And it's random because it's based on a random event, drawing a card from a deck. So put those two things together, we have a random variable. So we're going to create a model of this situation. Now in this case, a model is just a table to help us stay organized, to help us see what could happen. And just so that you're not surprised, here's what your book does. Your book uses the lowercase x to represent the different outcomes. Okay, so I'll write that in a different color. Okay, these are outcomes. And then your book uses this interesting notation, the probability that the random variable would take on that particular outcome. So in your brain, you're just thinking, okay, that's just a probability. And then we're going to keep track of all the different things. So thinking about the amount of money you earn, don't forget that you paid $5 to play the game. So if you get the ace of hearts, you get $100, but you gave me $5 to start with, so you're ahead $95. You could get another ace, so I give you 10, but remember you gave me 5, so you've only earned $5. If you get any other heart, you give me $5, I give you 5 back, so you're just even there. And any other card you lose, so you have lost your $5, negative $5. Now we're going to fill in the probabilities. For those who are not familiar with a deck of cards, there are 52 cards in a deck. There's one ace of hearts, so that's a 1 out of 52 probability. There are 3 other aces, that's 3 out of 52. There are 13 hearts altogether, but one is the ace of hearts. We've already used that. So there are 12 other hearts. And if I count that up, I'm at 16. So there are 36 other cards. So that's my model again, okay? This table, this thing is my model. Just kind of giving myself a picture of what's happening. Now that still isn't enough to really answer the question, should we play the game? So we're going to calculate what's called an expected value. Expected value. An expected value is just an average. But because we're talking about random variables, we use a couple special words. So expected value in your brain, it's just an average. It's an average over many games. So if I play this game lots and lots of times, how much money do I earn per game? Right? Because it's an average. Okay, so how much money do I earn per game? Money per game. And again, it's just on average. Now, here is the formula that you will see on your AP formula page. It looks like this. E for expected value of the random variable x. Okay, right here, x. And then we have this interesting, it kind of looks like an E. It's the Greek letter sigma. And this just means we add everything together. Little x with an I, the little i's just mean there's more than one. So x, these are these x's, the different outcomes. P, these are these p's for the probabilities. So what we have here is that we're going to multiply our outcomes times our probabilities. Okay, just make sure you can read that formula so you can recreate what you need to do. So I have an outcome, like 95. I'm going to multiply that by its probability. Okay, outcome probability. Sigma tells me I'm going to add everything together. I take an outcome, like 5, and I multiply it by its probability. I add them together. I take an outcome like 0, and I multiply it by its probability. And I take an outcome like -5, and I multiply it by its probability. You can put that all in your calculator at once. Just make sure you're really careful in your use of parentheses, especially with the fractions involved. Definitely take a minute to make sure you can work that out in your calculator. Your life will be easier if you solve those problems now, not the day of the test. When I did it, I got negative 1.35. So what does that mean? That means I am losing $1.35 per game. On average, I might win a few, but on average, I'm losing money every time I play this game. Should I play it? Probably not, because this says I'm losing money every time I play this game, on average. By the way, carnival games, any sort of gambling you will do in Vegas has a negative expected value. That's because they want to earn money from those games. All right, so I've copied our table, mostly, onto this slide, and now we're going to talk about the variance. So we did the expected value, which is like the average. Now we're going to explore the standard deviation, but we need to start a discussion with variance. So variance we refer to as the Staggering Theorem of statistics, and I'll tell you why in just a minute. So this formula here is also on your AP formula page, and I included a little piece of information. VAR is short for variance of the random variable x, and this is really important. We've seen this symbol before. That's our standard deviation. So this is to help you remember that variance is standard deviation squared. Okay, standard deviation squared equals variance. So then you might imagine if I wanted standard deviation, I would take the square root of the variance. Okay, so make sure you can keep that relationship in mind. So here's how we find the variance. It looks a little ugly, but we'll tackle it. We've seen this before. This symbol means we're going to add everything together. Okay, in parentheses, we have x. Remember, x is our outcome. Okay, so these are the outcomes. Mu, well, that's our mean, or our expected value. And then we're going to square that, and we're going to multiply it by the probability. All right, so let's do it. Let's find the variance. I'm going to help you write all this out, and then you're going to have some fun typing in your calculator. Okay, so I'm going to start here with this parentheses. I take an outcome. Here's an outcome like 95. I subtract my expected value. Now, don't forget, we've calculated the expected value of x on the previous page. It was negative 1.35. So I'm going to subtract a negative 1.35. Yes, I know, minus a minus makes positive. I just want to make sure you can see this minus comes from the formula, and this negative comes from the expected value. So I'll square that, and then I'm going to multiply it by the probability, 1 over 52. And sigma tells me to add. Oh, there's more? Yeah, I have to do this for every outcome. So I'll do it again. Here's an outcome like 5. I subtract the expected value. Square it, and I multiply that by the probability. Sigma tells me to add. There's more. Yeah, I have to do it for every single one of those. So again, here's an outcome like 0. I subtract the expected value squared, and I multiply that by the probability. And I add, because there's one more. I'll do this last one, the negative 5. My outcome is negative 5. I subtract the expected value squared, and I multiply that by the probability. Now, when you go to plug this in your calculator, I'm sorry, there aren't any great and grand shortcuts. So just make sure you're really careful in your use of parentheses. So you're just going to have to do it. You're going to have to tough it out. I know you don't want to do it right now. She's going to write down the answer anyway. Yeah, I am, but you should practice, because this is not fun or pretty to type in your calculator. When we're all said and done, here's how you can check your work. I got 190.496. I did round that off just a little bit. Okay, that's the variance. Phew. So the question might be, well, what about the standard deviation? So remember, we have this special relationship. Standard deviation squared equals variance. That means if I want standard deviation, I should square root. So standard deviation equals the square root of the variance. So if I want my standard deviation, I'm going to take the square root of 190.496, and I get approximately 13.8. So that's my standard deviation. You need to be able to get both of those items. All right, now the question might come, why do I call it the Pythagorean theorem? That seems really silly. So just to remind you of Pythagorean theorem we used when we had right triangles, and it was that a squared plus b squared equals c squared. So if I want to find this final side of the triangle, I don't just add them together, 3 plus 4, and get 7. That's not how it works. We square them first. It's 3 squared plus 4 squared. That's 9 and 16, so that's 25. But this final side isn't 25. That's c squared. I have to square root the 25 to get my final side. Hopefully you can see some parallels between that and our variance formula. To get our variance, we took a distance and we squared it. Okay? So hopefully you're seeing that relationship. We squared it just like you do here in the Pythagorean theorem. And when it's all done, we had a variance, but if we wanted the square root, if we wanted the standard deviation, we had to square root the answer, just like we did here with the 25. So that's just something that might help you remember a little bit about the variance formula and how it works.